My name is Dr. Bradshaw, and this tape is for my students in RAD 2612. I am covering structural analysis, and this would be page 2. For page 2, the first one on page 2 is basilar angle. And basilar angle is also known as Martin's basilar angle, or just Martin's angle. I am aware that National Boards is trying to get away from proper names. However, I still see Martin's angle show up a lot in state board exams and such. And so I still sort of say it both ways in class because I know that I still see it both ways on test. But it is my understanding that National Boards is trying to get away from proper names. For basilar angle, it has 3 dots. The first dot is called the frontal nasal junction. Now, depending on where they collimate the front of this film, as far as facial features being omitted, it might be difficult to find the frontal nasal junction, but it's going to be right here in this area. And the reason that I am aware of that is because it usually lines up with the top of the eye orbit, which is right here. Checking to see if I am off the edge of my film. Let me move the camera just a little bit. Don't get dizzy. And I'm going to focus in. Let me move the camera a little bit more and zoom in tighter. Alright, I'm going to back up just a little bit and do that again. You see this part right here would be the maxillary sinus. This part right here, the maxillary sinus, and this part right here would be the eye orbit. The eye orbit. Now, level with the top of the eye orbit, which is going to be right there. Moving on out, right in this is going to be a concavity or the bridge of the nose, and where the bridge of the nose is, it's going to be where the nasal bone meets the frontal bone. Now, a lot of films, including the one that I use in the labs, has a huge frontal sinus right here. So don't get confused with frontal sinus with eye orbit. Eye orbit, maxillary sinus, and there'll usually be a frontal sinus up in this area. Now, this person doesn't seem to have a huge frontal sinus at all. And so I would line up with, level with the top of the eye orbit. In fact, I even tell my students that if you can't see the frontal nasal junction, top of the eye orbit is a good alternative. And the second dot is in the center of the sella turcica, so I'd put it about right there. And then using my ruler, and I just dropped my pencil. I would draw a line from here to here, and that would be the first line for basilar angle. The next line is to find the front or anterior portion of the foramen magnum. Now, I'm kindly checking my film because I'm going to move the camera again, so hold on to your seat. And I'm going to move this down just a little bit because the anterior portion of the foramen magnum gives some people a difficult time. We know where the ADI is, and if you go straight north, it's like going to the Big Chicken. But if you go straight north of the ADI, you'll usually find a sideways V, white density. Now remember, periosteum shows up a little bit whiter than the inside of bony tissue. And so right here is my sort of V shape. So increased white density north of the ADI. All right, using the center of the sella turcica and the anterior portion of the foramen magnum, I'm going to draw my second line. And then that will be basilar angle. To measure basilar angle, we're going to use our protractor, and the protractor, you have to put the base of the protractor over one of the lines, the hole of the protractor at the junction of the two lines, and we're measuring from here all the way across to here. Now this one measures about 135. Again, from here to here, and this one measures about 135. Normal range is 123 to 152. If you had greater than 152, you might need to be concerned about platybasia and or basilar impression. Platybasia and or basilar impression. I don't know if you guys are picking up somebody's having a party outside the house in the neighborhood. I can't change that, so if you're hearing laughing and everything, the TV's turned off, it's the neighbors, and so you know how neighbors go. Anyway, moving on, the next one is called McGregor's line. And McGregor's line is going to use the superior posterior aspect of the hard palate. I'm going to move the camera just a little bit. And that is this white density that is right here. That white density that is right here. So the superior posterior aspect of the hard palate would be there. To the inferior or lowest point of the occiput, which would be usually about right here, because that is running along, right along there. Okay? Now we do have a mastoid process coming down right here, so don't take off on the mastoid. We are using the floor of the skull or the base of the occiput, and the lowest point I think would be about right there. So I'll line my ruler, well, I'll just use my protractor. I'll line my protractor up with those 2 points, and I will draw a line across right there. Now what I'm looking for is I'm looking for the odontoid process to not be more than 8 millimeters above this line for males, and not greater than 10 millimeters above this line for females. And when you look at the odontoid process, which on this film, it is this right across right here, and here's the back of it right there. Okay, so if I drew that in for you, that is the odontoid process. So you see that on this particular film, it's not any above the line. So on a paper, I would record this as 0, and I would move on with my life. But what I don't want to see is this above this line, more than 8 for males or more than 10 for females. If it is greater than either of those numbers, you would need to be worried about platybasia and or basilar impression. The next one on the list is Chamberlain's, and I'm going to actually erase this film of McGregor's, because McGregor's and Chamberlain's looks a lot alike. In fact, let me just, while I have this still on the film, this point right here versus the other point for Chamberlain's is how I tell them apart, because when you're in a testing situation, this dot plus the dot for Chamberlain's in this area looks identical. And so I tell my students, look back here to decide which one you are looking at. So I'm going to erase this, and I apologize that I'm doing this on the film, but I think it would be easier for you to see it if I take this one out so that you can see. And I'll just move part of basilar angle while I'm there. Okay, All right, so looking at Chamberlain's, Chamberlain's uses the posterior aspect of the hard palate. So again, that's this structure right here, not the superior aspect, but just the posterior aspect of Chamberlain's. So you see how close that would be as far as what it would appear to be on a film. And it also uses the posterior aspect of the foramen magnum. Now this can cause hardship for some people, but if you follow the back of the lateral mass, which is this structure right here, if you follow that up, you see that there's kind of a sideways U kind of shape right there, and that is the posterior aspect of the foramen magnum. So we draw a line using those 2 points. You draw a line using those 2 points, and again you're looking to see, is the odontoid above the line? Well, I've drawn in the odontoid process, so you see in this case it's not any above the line, so nothing to worry about. But if it were abnormal, we would not want the dens to be more than 3 millimeters. We do not want to see more than 3 millimeters of the dens above the line. If you do see more than 3 for Chamberlain's, you need to be worried about platybasia and or basilar impression. And then the last one on this page is called McRae's. And McRae's again is going to, see, I'm going to take out Chamberlain's a little bit just because to have it still in the film might confuse people. So let's just take that out of there. All right, McRae's again is going to use the posterior aspect of the foramen magnum and also the anterior portion of the foramen magnum. So again, here's the ADI. Go north. There's that sideways V right there. So the anterior part of the foramen magnum to the posterior part of the foramen magnum, and draw a line. Continue this line on towards the back of the film. And the second part of McRae's is that you want to draw a line that is perpendicular to that line at the apex of the odontoid process. So I'll draw this one like that. Okay, McRae's has 2 findings. The first finding is that you should see some bony tissue, and I do. You should see some bony tissue below the line. That's the first part. And we do. If we didn't, again, remember that the definition of platybasia is a flattening of the sphenoid and or occiput. This would be where we pick up that flattening of the sphenoid, or more importantly, the flattening of the occiput. Okay, so we're looking to see, is there any bony tissue below the line? And in this case, there is. The second part is that we're looking at this line, and does it fall in the anterior 1/4 of the foramen magnum? So if I'm looking at the distance from here to here, is that in the anterior 1/4? And it is. If it is not located in the anterior 1/4, we need to be worried about a fracture and or dislocation of the odontoid process. If you're looking at this space, this is a space that should be occupied by the neural canal. We don't want to find a den stuck back in this area. That would be bad news. All right, so on this page we have 4 processes to find platybasia. We have basilar angle, McGregor's, Chamberlain's, and McRae's. Of these 4 methods, McGregor's is considered the most universally accepted. And the most universally accepted means that you'll find other healthcare providers use it, used in courtroom testimony, used in depositions and research papers, but you'll run into it a lot more often than you will any of the other methods. Again, that's McGregor's is the most universally accepted. Okay, this concludes page 2, and I hope that you have a good evening.